Hello guys, today's lecture is on the software maintenance. Software maintenance is the modification in a program or modifying a program after it has been put into use. So this means maintenance phase start after the software deployment of software release, and software is released to the market or to the client site and its practical operation started. Then maintenance phase start. The term maintenance is mostly used for changing custom software. There are two broad categories of software: generic software and customized software. So custom software is developed on the demand of the client or users, and they must expect changes. Generic software products are said to evolve to create new versions. In generic software products that are designed for generic users, so new versions come. So both demand maintenance, but in different way. Maintenance does not normally involve major changes to the system architecture. So we does not change the system architecture, or too much changes are not expected, but minor changes, modifications are expected. Changes are implemented by modifying existing components and adding new components to the system. So types of maintenance. Three categories of maintenance. Fault repairs. So fault repairs mean changing the system to fix bugs, errors, faults, defects, any vulnerability, and correct deficiency in the way meets its requirements. If the system does not perform, or some features or component does not perform well, so this shows there are some deficiencies in different components. The deficiencies can be in the functional requirements or can be in the non-functional requirements. So this system then demands a fault repairs process. Another category of maintenance is environmental adaptation maintenance. Maintenance to adapt software to different operating environment. Sometimes a software does not compatible with all the operating systems and create issues when, for example, the new version of the operating system comes. Let's take example of Windows 11. So the existence of software can create problem, does not efficiently run. So what we then do, we do a maintenance, we do some modification, changing the system so that it operate in different environment. And in environment we talk not only about the operating systems but also talk about the system system hardwares, network infrastructure, etc. And then finally the functionality addition and modification, that is modifying the system to satisfy new requirements. So here new requirements come and are added to the system, and thus we say we have modified the system by adding new functionalities. Normally 58 to 60% of the maintenance is by modifying it by adding new functionalities. 20 to 24% is fault repairing process, and 19% is environmental adaptation. Remember, one thing is that fault repairing is not everlasting process. This means if we are running the software from 5-6 years, so less fault repair is expected, because if the software is run for a long period of time, this means this software either does not have any error, or error are already removed. So whenever the time passes, the percentage of functionality addition increases. Now come to discuss about the maintenance costs. It is usually greater than the development costs, 2 to 100 times depending on the application. Why? Because in maintenance we do modification to existing modules, components, architecture. So we must have to first analyze the existing architecture, the source code, the legacy system, and then bring change. So sometime, not all the time, it exceeds. Maintenance cost is affected by both technical and non-technical factors. Technical factors include system architecture, the code, the technology, etc. While the non-technical factors include factors such as training, documentation, etc. Maintenance cost normally increases as software is maintained. Maintenance corrupts the software structure, so makes further maintenance more difficult. Aging software can have high support cost. Aging means the old software or old language compilers, etc. So the legacy system with the old age become difficult to fix and modify. Maintenance cost is usually more expensive to add new features to a system during maintenance than it is to add the same feature during the development. Why? Because during development all the code is under the control. The same developer is doing the modification. But after the implementation, it is possible that the same developer and architect are involved, but it is not all the time possible. So after the implementation, modification become difficult as compared to bringing modification during the development. So during development, the modification, corrections, enhancement, improving the components and feature is easy as compared to modification after development. A new team has to understand the program being maintained. Yes, obviously, maintenance staff are often inexperienced and have limited domain knowledge. One more thing, that during development, all the team know what to do and what is the system. So they have already explored, they have documentation in their hands. But after development, they have to re-engineer, they have to reverse all the process and go back to the documentation process. Sometimes the document is not available or is lost, or modifications are too much, so difficult to control the change. As program age, their structure degrades and they become harder to change. So that is the case already discussed, that aging software is difficult to modify. Now discuss maintenance prediction. How to predict maintenance. So maintenance prediction is concerned with assessing, evaluating which parts of the system may cause problem and have high maintenance cost. Change acceptance depend on the maintainability of the components affected by the change. So it is directly proportional to the components, the nature of the components. Implementing changes degrade the system and reduce its maintainability. Maintenance cost depend on the number of changes and cost of the change depend on the maintainability. This diagram shows the three parts. First is predicting system changes. So two factors are involved. How many change requests can be expected? So it's also depend on the system. If it is a large system, it is a big project and contain a huge amount of requirements such as ERP systems. So the prediction request can be many. So there can be very too much request in such a system. And what parts of the system are most likely to be affected by change request? So it also depends on the business process. Sometime in organization, one department have change in policies. One department the policies changes abruptly, and in our last lecture it is discussed in detail that business process can be changed. So this means if business process change, it will demand more change in the features and characteristics. Predicting maintenance cost, two factors: what will be the lifetime maintenance cost of the system and what will be the cost of the maintaining this system over the next year. And predicting maintainability, what parts of the system will be most expensive to maintain. And this also depend on the architecture of that component module and then obviously the code structure. So if there is more code involved, more features and sub features are involved, so this means that component will be more expensive. Change prediction. Predicting the number of changes requires an understanding of the relationship between the system and its environment. So tightly coupled system require changes whenever the environment is changed. Remember that when the components or modules are tightly coupled, change become difficult also. So this also, if the module or components is independent and isolated, so this means it will not bringing change in that component, will not bring change in other component. So these factors should be analyzed. Factor influencing these relationships are the number and complexity of the system interfaces. Yes, the number of inherently volatile system requirements. Volatile system requirement means that these requirements are not fixed but rather can be evolved over the time, and that depend on the business, the nature of the business process and the goals. If we take example of the ERP systems, so the policies of accounting, the policies of marketing is the best example. So marketing policies can be changed. So if this constraint and business rule change over the time, this means the organization have to modify the business process, and to achieve the business goals and requirements based on the business process, the components should be modified accordingly. The business process where the system is used, so we should remember all these in mind. Complexity matrix. Predictions of the maintainability can be made by accessing the complexity of the system components. So complexity means how tightly coupled are the existing modules components. We should analyze the depth of the components, the breadth of the module, the non-functional requirements included by the particular module, etc. So these all should be kept in mind. Studies have shown that most maintenance effort is spent on relatively small number of system components. Complexity of the system depends on the complexity of the control structures, complexity of the data structures, objects, methods, and module size. Process metrics. Process metrics may be used to assess maintainability. It includes the number of requests for corrective maintenance, average time required for impact analysis, average time taken to implement change request, and the number of outstanding change requests. So if any or all of these is increasing, this may indicate a decline in maintainability. Now, software reengineering. It is a very important property that is applied and used during the maintenance. Reengineering includes restructuring or rewriting part or all of the legacy system without changing its functionality. So this means if we restructure, rewrite part or parts of the legacy system, old system, such that it does not have impact on the overall functionality, so this means reengineering process is started. And one more thing, that refactoring, which will be discussed in detail in upcoming lectures, and this lecture 2 slide description will be given, that refactoring is basically to improve the code for easy management. Reengineering is applicable where some but not all subsystems of the larger system require frequent maintenance. Reengineering involves adding effort to make them easier to maintain. The system may be restructured and redocumented. So redocumentation is also important during reengineering. Advantage of reengineering. The first advantage is reduction of risk or reduce risk. There is a high risk in new software development. There may be development problems, staffing problem, and specification problems. So reengineering, the purpose of reengineering is to reduce this risk. So in maintenance, if we apply reengineering properties, so that become easier for developer. Reduce cost. The cost of reengineering is often significantly less than the cost of developing new software. So reengineering is also better in terms of cost reduction. So this is the reengineering process diagram. Original program where we should bring modification. Source code translation. This means understanding the old code of the legacy system or original program. Then we apply the reverse engineering. So what is reverse engineering? In reverse engineering, we go back to the previous phases until we approach the program documentation. So program documentation is written in the start, but if the software is running and a program documentation is not available, so how we can then write it? So by applying the reverse engineering property, we can easily rewrite the program documentation. And then from program documentation, we modularized or remodularized the program, and then we apply the re-engineering process. We structure the program and we redesign. In short, we can say we redesign the program, and then from original data and re-engineering program, we have a data re-engineering. So re-engineering process activities are the source code translation, means convert the code to a new language. So source code translation can be also possible without new language, but mostly it is converted to new language in translation. Reverse engineering, analyze the programming to understand it. Program structure improvement means design improvement. Program modularization means reorganize the components, restructure the components, and this happens mostly when we are adding new functionality. And data engineering means clean up and restructure the system data. So increase when the cost is increased when we proceeds automated source code conversion, automatic program restructuring. So whenever we proceeds in re-engineering, the cost increases. Re-engineering cost factors. These are the re-engineering cost factors you can see, and it depends mostly on the quality of the software and tool support and the experience of the staff. So if the more and more experienced staff is working on it, tool is expensive, technology is expensive or unfamiliar, and the quality produced is more to be expected, so obviously re-engineering cost will increase. Refactoring. So refactoring is the process of making improvements to program to slow down degradation through change. So refactoring is actually the code improvement or enhancement in the code, or we can in short say that to make the code more beautiful, more efficient, more easy to understand. You can think of the refactoring as a preventative maintenance as that reduce the problem for the future change. So this means if we make the program more easier to understand, more and more efficient, so it will be a type of preventive maintenance. Preventive maintenance include prevention of the errors or less chance of modification for the future. Refactoring involves modifying a program to improve its structure, reduce its complexity, or to make it easier to understand. When you refactor a program, you should not add functionality but rather concentrate on the program improvement. So there is a difference between refactoring and maintenance. Refactoring is a part that can be included inside the maintenance, but maintenance is a quite generic and broad term. So here we don't need to add new functionality, but rather to improve the structure, to improve the code behavior and keep the functionality same. Re-engineering takes place after the system has been maintained for some time and maintenance costs are increasing. So there is a close relationship between refactoring and re-engineering. And in re-engineering, we re-engineer, we redesign the code. So this means the refactoring is involved here. You use automated tools to process and re-engineering a legacy system to create a new system that is more maintainable. Refactoring is a continuous process of improvement. This means we cannot say that we have 100% improved the code and no further improvement is possible. No. For you might have achieved the ideal level, but there is always expectation of new improvement. So refactoring is a continuous process of improvement throughout the development and evolution process. It is intended to avoid the structure and code degradation that increase the cost and difficulty of maintaining a system. Bad smells in the program code that should be understood. Duplicate code, if code is duplicated, same code is written, same or very similar code may be included at different places. So we should remove, if there is a need of duplicate code, we can just call that code. Long methods, if method is too long, it should be redesigned. You remember that long methods can affect the performance and efficiency of the program. Switch case statement, these often include duplication where the switch depends on the type of value. The switch statement may be scattered around a program. In object-oriented language, you can often use polymorphism to achieve the same thing. Data clumping. Data clumps occur when the same group of data items such as classes, parameters, methods reoccur in several places in a program. These can often be replaced with an object that encapsulates all of the data. Speculative generality. This occurs when developers include generality in the program in case it is required in the future. So key points that you should remember always is that software development and evolution can be thought of as an integrated iterative process that can be represented using a spiral model. So it is already discussed in detail that it is a continuous process. For custom system, the cost of maintenance usually exceed the development cost. The process of software evolution is driven by request for changes and include change impact analysis, release planning, and change implementation. Legacy systems are older software systems developed using obsolete software and hardware technology that remain useful for the business. So that was all about today's lecture. Thank you for watching. Thank you so much.